This will be our overview of ThinkCentral homework lesson 4.1. So in this unit we're going to be talking about multiplication and how it affects digit shifts or decimal shifts. Pretty simple concept if you know your place value chart. So what I'm going to do here is I'm going to draw columns to represent place value. So this is the ones place here, tens, hundreds, thousands, 10,000s, 100,000s. So if Jordan earns $454 a week, when you multiply that by 10, the digits shift where? Well, here you have 400s, and those are going to get 10 times bigger. Every time you move to the left, the digit gets 4 times bigger. So instead of 400, it turns into 4,000, like that. So every time, so after 10 weeks, each of these numbers is going to shift. The 4 is going to shift, the 5 is going to shift, the 4 is going to shift, and then we put a 0 here to hold the place value. So after 10 weeks, Jordan is going to earn 454 times 10, which is 4,540. Same problem here. Jordan earns $245 a week. When you multiply by 10, how many places will the digits shift? Well, we just covered that. Each digit is going to shift one place to the left. So the 2 will become 2,000, the 4 will become 400, the 5 will become 50, and you put a 0 right there. In this case, it's $522, but it's going to be 100 times. So it's a double shift. Each time you move, it's times 10. So times 10 times 10 is 100. So the 5 is going to shift twice here. It's going to become, instead of 500, it's going to become 50,000. Instead of 20, it's going to turn into 2,000, like that. It's a double shift. Instead of 2, it's going to turn into 200, like that. And then you put zeros there. So every time you multiply by 100, it's a double shift to the left. All right, this time it's a triple shift. So you have 3 zeros, 3 shifts. So the 2 will shift over 10 times, 100 times, 1,000 times. It's a triple shift to the left. You put the 2 there. The 4, 10 times, 100 times, 1,000 times. Put the 4 there. 2, 10 times, 100 times, 1,000 times. Put the 2 there, and you put zeros to hold the place value. So it's going to be 242,000. So the value becomes 1,000 times greater each time you with the triple shift. Same problem here. It's a triple shift, so just get used to drawing the place value chart. You have 500, and it's a times 1,000. Notice that there's 1,000 is 10 to the third power, so it's a triple shift. The 5 shifts over once, twice, and right there, so the 5 goes there. So Isabel will earn 500 times 1,000, which will be 5,000,000, 500,000. Simple situation here, 821 times 100. 100 is 10 times 10, which is a double shift, which is 10 to the second power. So we're going to take the 821 and we're going to add 2 zeros to it to get 82,100. The number of zeros in the product will match the number of zeros in the factors. 650 miles a day, 10 days, you got 650 times 10, 1 0, so we just take that 0 and we shift these digits one place to the left, and that turns into 6,500. This time same thing, except we're dealing with decimals, so instead of whole numbers you have decimals, but that's fine too. Each digit is going to shift. So let me draw my place value chart, put the decimal point here. You have 0.242, and so decimals are real numbers too. You're going to multiply it by 10, so each digit is going to shift one place to the left, like that, and the digit is going to become 2.4. The numbers are going to become 2.42, $2.42 to make 10 red phantom marbles. Same problem here, except it's a double shift because 10 times 10, so 2 0.245. Each digit is going to shift 2 places to the left, 1, 2. And I always, of course, like to draw my columns, so this is going to turn into 2. This is going to be the 4. This is going to be the 5. Don't forget your decimal point and fill in that. So $24.50 will be the cost to make 100 red Bantam marbles. Same problem, just a triple shift. So triple shift, 3 zeros, so 0.322. Each digit is going to shift once, twice, 3 times. Draw your columns to help you understand that. The 3 is there. The 2 is once, twice, 3 times. The 2 goes there. This 2 goes once, twice, 3 times. That 2 goes there. So it's going to be $322 for 1,000 marbles. And I put zeros to hold the place value. As I said before, the number of zeros will equal the number of zeros in the factors will equal the number of zeros in the product. So you have 60 times 40. What I'm going to focus on is 6 times 4. 6 times 4 is 24, and I have 2 zeros here, so I'm going to pop in 2 zeros, so it's 2,400 will be, that's not dollars, 2,400 will be our answer. Or 60 times 40, 2,400. The number of zeros in our factors equals the number of zeros in our product. How many zeros do I have here? I have 4, so I'm going to multiply 7 times 3 and 21, and I'm just going to add on 4 zeros, so the answer is going to be 210,000. This time we're talking about powers of 10, 10 to the 5th power. Remember, the base is 10, so the 5, the exponent up there, represents how many 10s you have. So if you see a 5, that means you're going to have 5 10s. So you put that, and you multiply 10 times 10 times 10 times 10 times 10, and that will give your answer. Well, 1 times 1 is 1, and you have 1, 2, 3, 4, 5 zeros. So 10 to the 5th power is 10 times 10 times 10 times 10 times 10, which is the same as 100,000. Very simple, 2 10s, that's 10 to the 2nd power. The exponent here represents how many 10s you have. So you have 4 times 10 to the 2nd power, which is going to equal to 400. All right, what do we got here? We got 3, and how many 10s do we have? 1, 2, 3, 4, 5. So 3 times 10 to the 5th power. And that is the same as 3 times 1, which is 3, and you pop on 5 zeros like that, 300,000. So 3 times 10 to the 5th power, because there are 5 10s, equals 300,000. All right, we've done this, but let's look for the pattern. You have 1 0, 1 0. 2 zeros, 2 zeros, so this would be 500. 3 zeros, 3 zeros, so 5,000. And this one, you have a 0 here and 3 zeros here, so you'd have 4 zeros, 50,000. The number of zeros in the product equals the number of zeros in the factors. And 10 to the 2nd power is 10 times 10, which is the same as 100. You notice the 2 zeros and the 2 zeros, so 3 times 100 is 300. Hopefully you're getting the hang of this. All right, that's shifting powers of 10. Remember, digits shift to the left. When we talk about decimal points, though, the same thing as a digit shift to the left is a decimal shift to the right. So like if I have 1.0 and I shift the decimal to the right, I get 10. But if I shift the digit to the right, I get 10. So it's the same thing, but just remember, we'll cover that in the next lesson.